Visual Basic 2010 game programming tutorial. In this video we will be covering the basics of game loop design, and also we will create a tick counter to capture our frames per second and see how well the program is running through our loops. As with the other videos, you'll find below it in YouTube in the information section the link to the download for the source code, so you can monkey with that or try your own stuff or just follow along, whatever you like. Alright, so let's get started here. Alright, so first things first, we're going to go ahead and create a new project. We want a Windows Forms application. I'm going to name mine, I'm just going to call it My Game. Hit OK. And excellent. So I'm going to go ahead and set my form size to 750 by 550. I'm going to be creating essentially a 640 by 480 grid. So it'll be kind of low resolution. We're going to be using 32 pixel tiles in this one. So let's go ahead and change our size here. I'm going to pull that up so you can see it. I'm just going to come down here, say 750 by 550. So I'm going to actually be kind of extending this over a ways. Essentially 640 by 480 is going to come to about here, and we'll have a little bit of a border around our application. And over here in the right frame we're going to show your ticks per second and all that fun stuff. So just getting started, you can kind of see how your system's performing. So we'll go ahead and save that and we will go into our code. So let's go ahead and drop in our graphics library so we can draw stuff. We're going to use imports system.drawing, and that will allow us to draw things to the screen and manipulate simple graphics. So I'm going to start by adding some graphics variables here above my form load. And first thing I'm going to do is create a graphics object, and that will be what we use to draw to the screen as we have in previous tutorials. Now I'm going to create a back buffer graphics object to hand off the back buffered graphics to the form to keep us from getting flickering when we try moving our characters around and whatnot. It gives you a nice smooth draw. The next thing we'll create is our back buffer, and it will be as a bitmap image. So it's essentially going to start out as a blank sprite that you're going to draw to and from using these graphics objects. And then it'll, as it's copied into memory, it will draw smoothly to the screen. And the last thing we're going to do, since I'm not actually going to be using tiles that I've created in this tutorial, we'll get to that later on in this series. I'm just going to do a simple rectangle grid. So ours is just going to be a rectangle. We're not going to be using source and destination like we did previously. That'll come later on. So let's start a group of variables for our frames per second counter, our ticks. So I'm just going to call it FPS counter. We're going to need a variable to capture the present time in seconds. So I'll just call it time seconds as an integer. And I'm going to set that to time of day, so it grabs the current time and the current second. Whoops, sorry. Time of day dot second. And then the next one we will do is the number of ticks. So we've got to keep track of those. So we'll just call it time ticks, also as an integer. And we'll just set that one to 0 to get started with, because we're going to increment it and then we're going to reset it, and then each second it'll count how many times our loop completed. And then we'll store that value as the maximum ticks. So we'll call it max ticks. I should probably keep in my naming convention here, but I'm just going to keep moving. So the next one we will do, or the next thing we will do, is track to see whether the game is actually running or not. You could use this to pause your game or things like that to actually break your loops. So we'll just call this game running as a note, and we'll dim that variable is running. If I could spell. And we're going to dim it as a boolean. Is it running? Yes or no? True or false? The default will be true. We want our game running as we come in. If you have a load screen where you want to load a game state or something like that, then you might not want it running right away. So it depends on if you have intro screens and stuff. Alright, so the next order of business is to tell it to show the form, because if we don't do this, the way that we're going to create our game loop, we're going to launch it right away, and if we don't tell it to show the form, it'll get trapped in that loop before it can ever draw to the screen. So we don't want that to happen. We want it to draw the screen and then focus on the form. So that'll be your primary window at the time of load. Next thing we will do is initialize our graphics objects. We'll say G, whoops, let's go graphics objects. Should probably say what we're doing here. We'll say G equals me dot create graphics. When we call me, that's telling the program to focus, or that we're actually manipulating the form itself. So form 1 up here is me at present. If we use other forms, me will then refer to them. Alright, so create graphics, and then create our back buffer image as a new blank bitmap. And the size of that is going to be me.width and me.height. Okay, so we just created a brand new image that is exactly the height and width of our form that we've created. And then at this point we would actually launch into our loop. So we'll just create something, we'll call it start game loop, and then we'll build a sub to actually use that. So we'll just drop down here and we will do private sub start game loop, and we will be ready to fire this thing off. Actually, we have another one we'll have to create first. So whenever you create a loop, especially a hard loop like we're going to do, you're going to need some way to stop that. Otherwise, you got to launch it and it's just going to freeze up your machine. So last thing we want to do is lock up our application. So what we'll do is we'll say do while is running equals true. Alright, now that in itself is not enough to keep this from freezing up our machine, because when we first come in here, it's going to be the value of this is set to true because we did that up here. So it's going to hit this, going to say it's true, and then it's never going to be able to break out. So what we need to do is monitor system events and other events that are occurring at that time, during the run of this loop. So what we'll say is application.doEvents, and this will just tell it to stay alert and wait for other messages. Anything that would be a key press, it has to know when we actually press the button. If we're trapped in a loop, there's no way it can tell that we're doing anything, so we just have a frozen app. So we'll just say keep app responsive. Okay. Alright, next up, well, we can kind of analyze how a proper loop should be created. And you know, there's probably going to be a lot of differing opinions on what a proper game loop is, but we'll just go through some of the main things here. Shouldn't be more than 5 or 6 steps that we have to monitor during our loop. So first thing might be, obviously check user input, right? You want to know when your players are pressing buttons and stuff and how to respond to that. Next might be checking your AI. Is there AI in your game? You want your guys to be doing things on their own while your game is running, or interacting with the characters and stuff. So you're going to have to go through all those routines during the cycle. How about update object data? That could be, object positions, status, anything. So just changing the values that are associated, and that could tie into this too. That could all be part of the AI. You're updating an NPC's coordinates or something as they're walking around, and things like that. So a fourth one, how about check triggers and conditions. Say you step on a certain tile, something has to happen, or maybe it's a battle sequence that begins, or an animation sequence, or story mode or something. So you want to check those things out, update the values before continuing on to your drawing. So changing the game data is of paramount importance. Obviously, you can see all these steps are changing background stuff that has to keep things alive. Otherwise your game will seem kind of static and dull. Things should be moving around in games. Next step would be draw graphics. Alright. Now, I said all this stuff is the most important, but this is really important too. You want your things to be drawn to the screen. That's what makes it, makes the whole gaming experience fun for the end user. So, and probably of least importance is playing sound effects and music. Okay. Now, yes, sound effects and music are very important, and of course we need them, but all of these other things should take precedence over things that don't actually do anything in your application, in your game. So you want to take care of all the important stuff first. So we'll probably just go in this order, and so we're going to need, we're already in a loop here. We're just cycling over and over and over as long as this value is true, checking to see if that true changes or if something else happens. That's what this is doing. So we don't have a solid loop that traps us. And last, I would say update the tick counter. Okay, and this is optional and will just consume resources in the end, but it's nice to know how well your loops are performing. If you're just really getting bogged down, it can help you optimize your code and stuff. So I think that this is a very important thing to keep track of. So let's go ahead and create the tick tracker. Before we get digging into graphics and things like that, we'll actually create our counter. I'm going to come down here, say private sub, whoops, tick counter. And then what we want to do is just monitor the seconds. And we want to know every time a second changes, we're going to actually start our counter over. And then we're going to record it to the max. We're going to take this number of ticks as it zips upward, because I mean this thing should be cruising through these loops really fast. And then it should record the max. Let's see here. If time seconds equals time of day dot second and is running, you know, if our game's paused, we don't need to keep running our counter. If it's running, then what we will do is we'll take t ticks equals t ticks plus 1. So every time this loop completes, if the second that it's running is the same as the last second, or I'm sorry, if the second it's running is the same as the last second, then continue to increment. As soon as the second flips over to the next one, we want it to reset. So we'll say else max max ticks is what we call it, equals t ticks. So we grab the last value it encountered before the second changed, record it to max, then reset your ticks. And then we'll grab the present second. So we'll say tsec equals time of day second. Alright, now that should just be whizzing through there. Now because we're not actually grabbing any graphics code here, we're not drawing anything to the screen, if we hit play, it's not going to show us anything but a blank screen. Even though it's running, it just means it's running successfully. So what we'll need to do now is actually get some graphics up here. That's my favorite part. So let's go ahead and jump into that. So I'm going to go ahead and just start creating that right here above tick counter, just because it comes first. And it's nice to keep your code kind of organized. You don't want it to get too messy, otherwise when you got to go change something, it's kind of hard. So we'll say private sub. We'll just call this one draw graphics. How about that? It's pretty simple. Now I don't know if you've watched my previous tutorials on tile mapping and things like that, but we're going to use the same techniques, just not drawing actual grass tiles and things like that. We're just going to draw simple rectangles and strings and things like that to give you an idea of what's happening while this is running. So our first order of business is to fill the back buffer. Okay, the back buffer needs some graphics added to it. That would be drawing the tiles, drawing strings, characters, anything like that. So our first thing should always be to draw the tiles, because if you don't, if you try drawing your tiles after you've drawn other stuff to the screen, it's going to write over top of that stuff that you've already drawn. So since the tiles are always our background, that should always come first. And we're going to create a loop inside of our loop here to loop through our tile coordinates. Very important. So we're just going to do for x equals 0 to 19. Okay, so that's 20 tiles across our screen. Because we're going to do a 640 by 480, that's going to be 640 pixels across and 480 pixels down. That's going to be our actual game grid. If we did have grass tiles and stuff, that's as far as they would extend. on our screen. So 32 times 20, this is 0 to 19 is 20 tiles, 32 pixels, that's going to give us our 640. And so we'll do for y equals 0 to 14. So we'll be 15 squares down, 20 squares across. And we're just going to loop through those every time and draw our background prior to drawing anything else. So at this point we're going to call our little rectangle. We're just going to say new rectangle. And it's always going to be the x coordinate times the size of your tiles. In this case we're using 32, so we get a standard Windows resolution here. And y again, so we've got whatever these coordinates are as they loop through, we're going to take that number, it'll be 0 times 32, 1 times 32, and it'll just keep incrementing up until it hits the top, and then it'll start incrementing y as well. And then again we're going to say the width of the tile we're creating is 32 pixels by 32 pixels. Alright? Now, after we've defined that rectangle, it's just an empty box, we're going to draw it to the screen physically. So we'll say g.fill rectangle, and I'm just going to use burly wood as the color. It's kind of a nice light tan, and so that's our brush, and then we're just going to draw it to our rectangle variable. Okay, so we don't have, you could punch in all these manually if you wanted to tell it exactly where on screen, but we need it to be dynamic and actually use those XY coordinates that we're looping through. So that's why we're doing that. And we've just sort of recorded those XY coordinates to this rectangle to further simplify things, much less typing. G dot draw a rectangle, and this time I'm going to use black. I just want a black box around our square to create a grid. Alright, now the reason I chose this order, if I chose to draw my rectangles and then fill my rectangles, what happens? Well, you know, you're going to have a bunch of rectangles on your screen using this, and then this is going to come along and overwrite everything with filling. So you want to fill in the background. Always think of the layers of your images. You want this first, so you have a blank canvas that's burly wood color, and then you draw the empty rectangle squares that are black around those boxes. Okay, that'll make more sense as we kind of go through it. So this is, you could think of this as your first layer. Okay, if you think in layers, it's kind of helpful when you start doing all your graphics and whatnot. So down here we'll draw our final layers. Alright, and it's good to keep notes for yourself so you know what different parts of different pieces of code are doing. So this could be guys, menus, you know, anything that comes after the fact. If you have a menu, you want it to appear over top of your guys. So again, we're getting kind of into the order of the layers and stuff, and you'll have to experiment with those as you go. You know, chat boxes and stuff should usually pop up over top of everything, and your character should, you know, be over top of all this. So we're just going to go ahead and draw a string here. This is actually going to paint text to the screen. What we want to record is the number of ticks as they increment. So I'm gonna put this string, and then I'm going to call my variable t ticks, And if that works, it should draw it to the screen as it's ticking up every time it loops through, which should be super fast, faster than you can actually see, really. I mean, you should actually see it as kind of a blur. And then we're going to add another line. VBCR LF drops down a line, so it's like hitting enter. We'll put TPS, our ticks per second, as our max ticks, okay? And we're going to have to tell it what font to use. I'm just going to use the default form font, so I'm going to say me.font. You can create your own fonts if you want bigger ones or different colors or other fancy things like that. The brushes, I'm just going to draw in black. And I'm going to tell it to draw this on the right side of the screen after our grid. So we know that this is going to be 640 by 480, so I want to draw beyond 640. I'm just going to grab 650 so we're not off the screen, and 0 as my y coordinate, so it should draw right at the top and as far to the right as I can there. So if that works, it should show us our graphics, our ticks ticking up there. Alright, so next up is to copy your back buffer to the graphics object. Alright, and then we're going to use that as our palette to draw back to the screen. So I'm going to say g.graphics from image. Whoops. I did not want dot, I want equals. G equals graphics dot from image. And what is our image? Well, it's our back buffer, BB, that we created up here. That's the same size as our screen. 0. Let's see, I want to draw it at the topmost left corner of the screen. That's where it starts drawing, and of course the size we want it to draw to is whatever the screen size is. So me.width again, and me.height. Alright, if you you could tell this to always draw at 640 by 480, but what happens is if you change the size of your screen, it won't scale up with it, so it'll just leave it there. You can stretch your screen out as big as you want. If doing this, if this changes or if this changes, it will stretch it by itself. Okay. Let's see here. Oh, you know what? I made a dumb mistake. As you can see, I'm copying my back buffer to the graphics object, but BB already has its own dimensions and whatnot, so I'm not actually drawing to the screen here. I need to get rid of all this junk. I'm just going to cut it because I'm going to need it again here shortly. All it needs to know is that it's getting its image from the back buffer. So it's actually much simpler. Down here is where we want to actually draw the back buffer to the screen. So we'll say draw back buffer to screen, and we'll take our back buffer graphics object that we created earlier, and we're going to change it to be the one to create graphics, okay, to the screen. So sorry, that's me.createGraphics. And bbg dot draw image. Okay, we're not using from image this time, we're actually drawing that image. There it is. And obviously the image we want to draw is our back buffer. And here is where, maybe I can just paste that in. This is where I want to actually tell it where to draw. Okay, so now I'm saying draw this image to these coordinates, 0, 0, always in the top left corner, and as wide as the screen is and as tall as the screen is. because we want that to go all the way across, not just to be fixed. Now in some games you may very well want it to be fixed. There are a lot of games that have like a game panel in one corner or another, and you don't want that size to change even if the screen size changes. So just kind of depends on what you're after there. You could fix those heights and widths. Now I think it'd be a good time to actually go through and run this and see what we get on screen. I'm going to save my project here just in case something goes horribly wrong, and let's go ahead and run this. Alright, nothing is happening, and I think I know why. What we forgot to do is actually call this in our game loop. So our game loop is running away, but draw graphics is not being called. So let's come up here in step 5, and I'm just gonna put that right in there. Silly me. Now let's try running it. Hey, that looks good. Now as you can see, we're drawing 19 tiles over and across, and if we try scaling this, oh, it grows. But you'll notice some weird graphical artifacts here. That's because we're taking that back buffer and drawing over it super fast, and as you can see, these ticks and whatnot, they're just, you know, zipping through and drawing, but they never get cleaned up. So what we need to do is clean that back buffer when we're done drawing. So cleaning up your palette is kind of important. We'll go ahead and stop that, and this is really easy. All you got to do is come to the very end of your drawing code, and we'll just say fix over draw, and we're going to take our graphics object G. Remember, we set that to the back buffer image, okay? So G is this picture now, and we are going to clear it. Whoops. And it's going to want a color to clear it out with. So as a background color, let's do something a little different than that burly wood, so it kind of stands out from the rest of the background. I'm just going to do like a wheat, so even a lighter tan. And let's see what happens when we do that. Look at that. Okay, now it's behaving like it's supposed to. Every time it loops through, it will refresh that palette, that screen, and draw us a fresh image. So you can see this is kind of just blazing through. This is every 1 second, every time that time changes by 1 second, we are going through on an average of 60 ticks per second. So now, you know, as a frame rate, that's probably not awesome. I don't think I'm not sure how GDI uses the graphics, your graphics card and whatnot, if at all. It's not probably not the best way to process imaging and stuff. You know, you could use things like DirectX and stuff if you really wanted better performance with graphics. But for our simple application, this is good, and this is really pretty good still. I mean, you're thinking you're flying through your loops this fast. You know, you can have a steady, smooth animation even at 25 frames per second. So I don't think it's a problem at all. You can do a lot with this, and you'll notice also that I can move this around. That's because we use that application.do events. Otherwise, it would not even know that I was launching mouse clicks against this application. It would be in such a solid loop. If we change the size of this, it should, because it has less to draw or more to draw, it should affect our ticks per second rather dramatically. So let's try shrinking this just for fun. You'll notice that it snaps to the screen size, and we didn't gain much performance on that. Let's see what happens if I make it really big. That kind of affected it a bit. So the more it has to draw, the slower it's going to draw. That's a lot more pixels to draw. So not super efficient, but again, for any old style RPG or something, that's going to be just fine. So trying to think if there's anything else that I should put in this particular tutorial. In the next tutorial, what I'd like to get into is handling mouse position and things like that. You know, character movement's very important, but I have covered that in other videos, and you can watch those other videos for an idea on how to do that. Mainly, I just wanted to capture our frames per second and things like that. This would go up quite a bit if I turn. My recording software is kind of bogging down the system a bit. It should probably, at this size, probably be up around 80. Anyway, I hope that this has been helpful to you. We'll get started again pretty quick here on the next video, so we can kind of, what we'll end up doing is making it so we can track our coordinates. We'll have our world coordinates like in the other videos. Then later on we can get into adding tiles and stuff, but one thing at a time. I will catch you guys later, and I hope that this was helpful. Thanks for watching. Bye-bye.